Good afternoon. Welcome to today's webinar sponsored by OnApproach and the CU App Store. My name is Pete Kiers, and I'll be your moderator today. I'm Partner Manager for OnApproach, a QSO focused on data and analytics. Through its M360 Enterprise Data Warehouse solution, OnApproach provides credit unions with the means to transform their data into action that benefits members. We've also launched the CU App Store. The CU App Store is a global marketplace for applications that help turn OnApproach M360 data into reports and analytics that provide valuable insights for credit unions. With applications developed by both credit unions and vendors, the CU App Store provides the industry with a place to build and share analytic applications. Check out the CU App Store at www.cuappstore.com. Our topic today is which CECL model should you use? Choosing the right model for CECL is crucial. Which one works best for your loan products and your data set? This webinar will cover the trade-offs in model accuracy, complexity, and the need to include Q factors as you move across the modeling spectrum. Our presenter today is Joseph Breeden, COO and Chief Scientist of Deep Future Analytics, LLC, and founder of Prescient Models, LLC. Dr. Breeden brings more than 20 years of experience leading financial institutions through financial modeling, allowing clients to achieve real understandings of portfolio dynamics for retail lending, where those problems originated. He currently serves as Associate Editor for the Journal of Risk Model Validation and is author of Living with CECL, the Modeling Dictionary, and Living with CECL, Mortgage Modeling Alternatives. There will be a Q&A at the end of the presentation. Please feel free to ask via chat or the questions function during the session, and I will read those during the Q&A. So with that, Joe, I'll turn the presentation over to you.
All right, thank you. Good morning or afternoon, depending on your time zone. We're going to go through today and talk about choosing a CECL model. Part of what we're going to do is to put this in context of previous generations of new regulations that we've had to adapt to, specifically stress testing, CCAR, and internationally IFRS 9, which is related to CECL. All of these things have given us insights into the process of choosing the right model for the job and how we go about that. So we'll start first with how do we choose a model, and then we'll talk about some of our experimental results from the studies we've run. The studies here leverage term loans, mortgages, that kind of analysis. Hopefully by Q4 we can give another webinar with our studies on credit cards, and that line of credit products have some of their own nuances to consider, and they will change what model you might choose. So some of our discussion late in this broadcast is more specific to term loans, and I'll try to come back to this point. So starting assumptions. Before you get here, the hope is that you will have created a CECL management structure. Who's in charge? And this is important. It's part of the model risk management guidelines, is that you need to know who's in charge of creating the models, who owns the models from a user perspective, who validates the models, who audits the models. These can be internal or external. In some cases, they can be the same person or different people, but it needs to be clear. You need to read the CECL guidelines. They're not small, and there are lots of additional commentary. It's just part of the hard work that goes with this. And you should determine what data you have. And of course, OnApproach is a good source for discussing the data items. So we're not going to dwell too much on these items for this talk. If you haven't done any of these, of course we can help. And we have other talks that talk more about these. But today, let's talk about models. Now, we have seen plenty of conference presentations by regulators and by consultants who say, here's how you choose a model. Step one, implement a bunch of models. And some people say, implement all the CECL models, number of models. There isn't. There's no such thing as the list of CECL models. Step two, choose the model that's right for you. Well, this is wrong. I'm sorry. That is not how you choose a model. We have guidelines for how this should be done. This is called model risk management. Model risk management, if you go through, the guidelines are well established. They are issued by all the different regulators, and they are flexible based on the size of the institution. Just like a moment ago, item number one, read the basics of model risk management. Okay, that's what I'm talking about. We can provide some links to some of these basic documents. Item number 2, establish your CECL model risk management framework. This comes back to that point I said, who's in charge? And so if you're a smaller institution, you may have one person who's in charge of choosing a CECL solution, and he's going to be the user, the owner of it. Ideally, you have someone else who's in charge of validation, because usually you don't want the business owner and the validator as either the same person, or you don't want the validator to report to the business owner. This is part of the checks and balances that go with model risk management. If you're a larger organization, you'll actually have teams for these functions as opposed to one person here, one person there. That scales with the organization, but the need is still the same. Next, you have to decide how you will choose. What is your metric? You can't implement models and then decide which one you like without first deciding how you're going to choose. And sometimes the metric that you decide for how you would choose the best model changes which models you build in the first place. And so we will talk about that. Decide which models are valid candidates. Some models simply don't apply. I'll give you a simple example. If you look at the publicly available Fannie Mae, Freddie Mac data, it doesn't have refreshed FICO scores, probably a licensing question. And so if you were going to build a model off of that data, you can't build a FICO migration model. Now, FICO migration models are not on the CECL list. That list of, there have been several documents that said you may want to choose one of these, and they give you some examples. They constantly reinforce that it's may, that's not an exhaustive list. So if you have refreshed FICO, you could build a FICO migration model. But if you don't have it, you can't build it. And you shouldn't feel like you have to build that model if you don't have that data. So some models make sense and some models don't. And it depends on the type of product you're looking at. If I'm looking at rated securities, well, then I'm probably going to use a grade migration model because I have ratings. And some other model types don't make as much sense there. Okay, so you choose your set of models. And again, we'll come back to this point on what are the candidates. Then you want to create the models. Or if you're using a vendor, it's this discussion of how have they chosen their candidate models and how have they implemented them. It's a review process. And then the last one is going to be, how do you choose the best model according to your model risk management criteria, or how has your vendor chosen? So in deciding how to choose a model, let's be clear right off the top. You won't have enough data for a lifetime validation. Now, why do I bother to make this point? It's because the model risk management guidance says very clearly that you should be validating your model on a forecast horizon equivalent to the application horizon. So if I'm doing a stress test model for 2 years, I need to validate on a 2-year period. If I have a 5-year auto loan, I'm supposed to validate over a 5-year forecast horizon. Well, the reason I say you don't have enough data is that the best data sets I see today go back to 2001. That's the very best. And if you go back to 2001, that means you basically have 1.5 recessions. Recessions, economic correlations are part of your model. So going back over 1.5 recessions, that's barely enough data to build a model. For your out of sample test for a lifetime model with an economic component to it, you should be testing on a recession. But we don't have another recession yet. We might in a few years. You might have data that you can use to build and validate separately. We don't wish for such things, but when it happens, we're going to be keeping all this data. But the model risk management guidelines give you flexibility. They do say that if you don't have enough data to meet this, then you should explain why. You should do the best you can. So along those lines, doing the best you can means that don't think that a 12-month validation period is enough, because what we will show you later is that the performance of these models depends very strongly on how far in the future you look. And the closer you can get to lifetime, the more correct your model choice will be. Now, you need to choose some appropriate metrics. Accuracy makes sense. We're going to talk some about procyclicality. There are some other things, but keep in mind, you're going to have to defend these models. You have to decide the criteria you choose, you'll have to defend to regulators and auditors. And I advise you not to put on your list that it was the highest number of the models you tested, or it was the lowest CECL number of the models you tested, or it had the lowest volatility. CECL will be volatile. The new criteria for how we do loss reserves mean that your loss reserve changes through the economic cycle. So all three of these things are not appropriate either for CECL or for model risk management practice. So you're going to need criteria other than it's the one I liked best. It cannot be an intuitive assessment. It's got to be something that you can document. Here were our criteria, and here's why we chose it. Then you have to decide which models are candidates. Not all models apply to all products. There are some universal types. A state transition model, usually the states are delinquency states, but they can also be grades that you assign. There can be various kinds of states. For credit card, it might be transactor, revolver, and then delinquency. And so a state transition model predicts transitions between states. It's a pretty generic thing. Vintage models that use a PD, EAD, LGD framework, they're also very generic. They work for almost everything. So there's some very general ones, but then there are some data specific approaches like the FICO migration model that I mentioned. So we actually have a book that was mentioned at the intro. You can find this on Amazon. It's as cheap as we could make it because we're just trying to get it out there. It's a dictionary because, first of all, we found a lot of confusion about how to define models. I'm going to disagree right now with some information you will read where some people try to distinguish between a static pool model and a vintage model. If you look at 20 years of academic literature, there is no difference. A lot of recent presentations have said that vintage models are only annual loss rates on annual vintages, and that's not true. That's not even close to true when you look at the academic literature. So our dictionary tries to stick to the documented definitions of things, and that's why you might find a few disagreements with some conference presentations, but I hope you like the choice we've made there. So anyway, that dictionary is just created so that when somebody says we've made this kind of a model, you have some context for that, and you can also just browse through for ideas. Since you don't have enough data for a true validation, you're also going to have to look to industry best practice. And for the studies that we've done, and we'll show you some of those results, we've already gotten feedback from people who said, this is great, it's a soft validation. And I really like that term. It's not a hard validation of this is your product, your data, and your validation. It's an example of this is industry data, an industry model, and an industry validation. And that's useful. It can help you in the pre-screen stage. When you see our results and you say some of those models just don't look like what I want based on the industry performance, it's unlikely they're going to perform better on your data because we're testing on some huge data sets here. In other words, this is as good as they're going to get. If you don't like what you see here, don't think it'll get better on your internal data. Things only go down as the data sets get smaller. It's a pre-screen, if you will, on models. Along these lines, the mortgage modeling alternatives, I've given some other talks on this. Last year we released this study, and in Q1 we released the book form, and again, made this as cheap as we could. This is not to make profit, as you'll see. But the idea is just to thoroughly document how we built each of the different types of models for mortgage and thoroughly document how we validated them. Basically, you can view this book as just a very large model documentation. So the kinds of things that we'll show in this book are the kinds of things you would put in your own model documentation. Okay, so that's my conceptual introduction. In fact, we do training courses on model risk management, and there are books and articles out there, and we have some of our own we can provide. The first third of this talk is really just to make that point, to emphasize, learn about model risk management if you don't already, because it's the best way to get your results accepted by a regulator. You will get immediate respect from a regulator or an auditor if you start from, here is the model risk management guidance, here are the principles we followed, here's the documentation for the choices we made. It sets you up to succeed, because what you don't want to do is show up with a model and answer a lot of their questions with, I don't know, or it looked right. So following that process is just a way to win those conversations. So lessons learned so far. We have run lots of tests. The mortgage data set that I mentioned is a great one because you can replay these tests. This is not a secret data set with secret models. It's a public data set, and we've published all the model calculations, so you can repeat anything in here you feel like. We've put them in some different categories here. There are some spreadsheet methods. Spreadsheet methods, that's my term. It's just methods that are simple enough that anybody can code them up in an hour or so in a spreadsheet. And FASB and some regulators have been trying to say simple is easy, or sorry, CECL is easy. Let me show you a simple way to do that in a spreadsheet. And they have historic averages. WARM, weighted average remaining maturity. It's just a historic average multiplied by the average life of the loan. So instead of your historic average multiplied by the 1 year loss, well, instead of computing a 1 year loss rate, you're computing a 1 year loss rate times 2.5 years for a 5-year auto loan, or times 7 years for a 30-year mortgage. So pretty simple. Vintage copy forward, this is where you say the previous annual vintage in the previous year had a 1% loss rate. So apply that to the next annual vintage in the next year. It's just kind of a roll forward of your annual vintage loss rates. Again, pretty simple. It does capture a little bit of trends in credit quality and a little bit of trends in the economic environment. The third one on the list, loss timing. This is also called a hazard function or a survival function or a life cycle. It's just saying in the age of a vintage, when do the losses usually come? What is the loss rate versus the age of the vintage? And just apply that. Under the statistical models, we've got a set here where the first one, a time series model, it just takes your historic loss rates monthly and correlates them to economic factors. And there are a number of papers that publish models like this. In our own version, we actually make two rates, a loss rate and a prepayment rate, or a total payment rate, if you will. And those two rates are correlated to economic factors. The next one on the list, roll rates. This is where you just have your accounts bucketed by how many months delinquent they are. And you look at the rate of what's the ratio of accounts that are 1 month delinquent this month to current last month. Maybe that ratio is 1%. 1% of accounts go from current to 1 month delinquent. Then you've got the ratio for 3 to 2 and the ratio for 4 to 3, all the way down to charge off. Each of those ratios makes a time series. And so it's really just like the time series model, but instead of just a charge off rate, now you've got these delinquency ratios that you're modeling. And usually for simplicity, people model just balances. What's the dollar balance in bucket 3 this month divided by the dollar balance in bucket 2 last month. The third one on the list, vintage model. This is what we consider this is a statistical vintage model. This is not something you do easily in a spreadsheet, but there are standard algorithms out there. In R or SAS or any other major statistical package, they're already written. You can pull up an age period cohort model and drop in your vintage aggregate data, and it will measure for you life cycle, credit quality, and economic environment. And then you can use those pieces to run forecasts. And if anybody's interested, I wrote an entire book in 2010 on exactly how to do that. I don't want to write that book again, but everything in there still works, and you can use that for CECL as well. And if you're interested, that book's called Reinventing Retail Lending Analytics, and it's on Amazon also. State transition model, I described this earlier. That's where you can have any states, and the difference between a state transition and a roll rate is just aggregate time series. State transition is account by account looking at all possible transitions. If I'm bucket 2 today, I can miss another payment and go to bucket 3. I can make 1 month payment and stay in bucket 2. I can make 2 months payment and go back to bucket 1, or I can cure all the way back to current, or I could charge off, or I could pay off because I've gone out and refinanced or sold my home or whatever it is. So there's a lot of transitions to model there. State transition models are pretty sophisticated because there's a lot to model. The last one on the list, survival model. The specific version we use, the one we like best, is a multi-horizon discrete time survival model. It's enough to know that this is a survival model. It's essentially a loan level version of a vintage model. And the one we've created for this study is a combination of vintage modeling and behavior scoring put together in the best way so that you get a loan level CECL. So those statistical models, you'll see all those test results. Not tested on here. This goes back to FASB lists on the list of types of model that you can use, PD models. Well, PD is not a model. PD is a thing to model. I can make a time series model of PD. I can make a vintage model of PD. I can make a survival model of PD. PD is a variable, not a model. Some people call what they do PD models, and to be fair, FASB just went out. It's clear what happened was they simply polled people and said, what kind of model do you use? Some people said PD models, but that's, yes, if you look at Basel II regulations, those are PD models, but it's a specific kind of model underneath. So it's not really the right use of the term. You get the same problem with discounted cash flow. Discounted cash flow is not a model. Anybody who's implementing discounted cash flow, ask them, where do you get the cash flows? Well, you need a model for that. So the actual cash flows come from something under either the statistical methods or the spreadsheet methods. Then you discount it. So discounting is really an aggregation method. So you won't see any mention of DCF in here because it's not a model. Regression. Also, we see people list regression models. Well, regression is a way to estimate the coefficients. Everything on the statistical models list uses some form of regression. Time series, roll rate, vintage models. A survival model, if you're a statistician or have some background, you'll know that they use a maximum likelihood estimator, but when you go to discrete time, that simplifies down to logistic regression. Almost everything on this list simplifies either to logistic regression or linear regression. So regression is not a model. Okay, now I'm done talking like a statistician. Let's do some more about results. So what does all this mean? Well, we ran lots of tests and we looked at forecast accuracy for different terms and looked at lifetime forecasts. And on the scale of this graph, I'm sorry that the dashed lines don't show up as dashed. That's just an Excel thing. Sometimes if there are too many points, it doesn't show the dash as well. But I will point it out for you as we go through model by model. How does the forecast error scale with the term of the loan? Basically, how long a forecast do you have to run? And the spreadsheet methods are easy to spot on this list because they're the 3 at the top. They are the worst. And it's not a surprise. Simple and accurate are not the same thing. If they were, life would be easy. But as you will guess, the more complex are the most accurate. That's just how these things go. So the question is, are the simple ones good enough? And I would say if you're forecasting on a 6 or 12-month horizon, if you've got a 1-year personal loan, you notice that all of these models are kind of in a clump down here at the bottom, pretty similar. If you've got a 6-month loan, same answer. But when you get beyond a year, these differences matter. So if the term of the loan is a 5-year auto loan, that says that your historic average model, what we call warm, that model is going to have a 40 or 50% loss rate on a 5-year auto loan. 50% loss rate It's pretty huge. Let me put it this way. To be fair, what FASB does is they know that these spreadsheet methods don't include economic overlays, they don't include recent credit quality changes. There are lots of things that a good model would include that they don't, and so you have to use Q factors. What they don't tell you is where those Q factors are going to come from. In the example they gave for how to use warm, they said, and you'll want to include we used a Q factor of 0.12 for economic impacts, meaning greater than average, roughly speaking, a 12% increase because the economy is deteriorating. Well, how do they come up with that? They never say anything about how to get Q factors. And I've been doing this for 20 years, and I will tell you in all sincerity, I don't know how to estimate Q factors. That's why we build models, because there's no simple back of the envelope that's going to give you an economic Q factor overlay or a credit quality Q factor overlay. So I sympathize for those who need to do a spreadsheet model and are going to use a Q factor, but I don't know how you're going to get those numbers. Okay, the statistical models are a more straightforward conversation because these are supposed to capture everything. You should not have to use, when I talk about Q factors, really, if you go through the list of all the Q factors that people usually talk about, some of them are for things that should be in your history. How have you changed your credit quality? How have you changed your underwriting? How has the economic environment changed, and what scenario might you use for the economy in the near future? Any policy change, any economic change that has already happened, a good model will pick up on. So for any model on this page, the only Q factor you need should be for things you haven't done yet. And I'll give you an example. We talked to a client where our model was diverging from recent performance. We raised the issue. They said, well, we've made a change in our collections policy. So we've accelerated charge-offs for now, but in the near future, that's going to work itself out and you'll be returning back toward normal, and our performance should return back to your model. Okay, we can't know that because it hasn't happened yet. So that is a good example of the proper use of a Q factor, where management is going to have to say, currently the model predicts this, and the losses are coming in high, but they will return to our general expectation. And so you'd actually have a negative Q factor in there for bringing current numbers back down to normal. Okay, looking at the ones on this list now, let's return to how do these models perform. The three at the top here, roll rate, state transition, they are both very accurate in the first 3 months. They're among the best we have. And then they deteriorate after that. Why is that? I should tell you right now, state transition models are very popular, especially in mortgage. There are some very large organizations who, I would say, to be fair, they probably haven't had to use their state transition model in the past for anything more than a 12-month loss forecast or a CCAR stress test. And they have not had to do this kind of a test on lifetime accuracy. But the challenge with roll rate and state transition is that they focus very specifically on delinquency. And delinquency is the most important thing to put in your model for the next 6 months. But beyond 6 months, delinquency is almost unimportant, because any account that's around beyond 6 months must have either cured or charged off. So if I'm doing a long-range forecast horizon forecast, if the account's delinquent today, whatever that delinquency was is going to work itself out in the next 6 months. So for a CECL calculation, delinquency matters a lot for short-term products. If I have a 1-year personal loan and the account's 2 months delinquent, that matters a lot. But if I need a CECL answer for my auto loan portfolio for 5-year, 6-year, 7-year term, it turns out your delinquency inventory doesn't actually matter that much for when you're looking at a 7-year forecast. So that's why the accuracy falls off so dramatically for the roll rate and state transition models. The time series model doesn't use delinquency at all, and if I zoom in on this first 6 months, you'll see it's not very accurate in the beginning. It's the one at the top, so it doesn't start out very accurate, and it also doesn't look at credit quality. It doesn't look at the credit cycle, so it deteriorates quickly there. Bottom two are the vintage model and the survival model. And yes, I wrote a book years ago on vintage modeling. So if you ask me if I'm a fan, I will say yes, I like vintage models, but that didn't cause the results to come out well, right? As I said, we put all of this in our Living with CECL book, so you can see exactly how we did it to make sure the test was fair. But the truth is, why do vintage models work for long horizon products? It's because they have a life cycle, that loss timing function. If I'm looking beyond 1 year, that's really important. And it's also really important to pay attention to credit quality. And so vintage models, ironically, are one of the statistical models. They're one of the least accurate for the first few months because they don't pay attention to delinquency at all. But beyond 6 months, they're very accurate. And so vintage models, if you want something that is as simple as you get and yet as accurate as you can get, they're kind of a sweet spot, the age period cohort models. Now, the survival model is the winner across the board because it combines these things. It combines the delinquency and behavior scoring data with vintage modeling, life cycles, and credit quality. So by getting the best of both worlds, you get the bottom line on here. It's a lot of work. I won't pretend they're not. Okay. So what that means is that if you want robustness to small data sets where the portfolio has charge-offs but less data overall, then you're going to have to use something like a time series model. So you may have, even though I said they're not great models, you may have a small portfolio where it has some charge-offs but just not enough to get any richness in the modeling. So in that case, time series models work, or vintage models are pretty robust to thin data sets as well. If you have very few charge-offs, this may be a prime mortgage portfolio or a prime commercial lending portfolio where you're just not getting charge-offs. Then you could focus on a roll rate or a state transition model where you really look at early delinquency and then use a constant charge-off rate for the later buckets. It's not a bad approach. Or another remedy for both of those problems, get more data, and shared data pools are one approach. And if you have questions about shared data pools, keep in mind that the FICO score is the result of a shared data pool, okay? They went out and got bureau data from something like 10 of the largest lenders and built a model off of that. Now, FICO score is not a loss model, it's a relative scaling. So what we do, Deep Future Analytics also has a shared data pool. OnApproach, of course, is also working on the data lake concept. And the idea is that where your data may be thin, when it's combined with a lot of other organizations, now you can build a really good model from all of that together. And as far as, I do want to make one point about shared pools. There's a lot of confusion that happens about how to prove that you're like the pool. And the confusion is because if you do a peer group study where you compare your loss rate to a group of peers, then you want to be as close to your peers as possible. A shared data pool is the opposite. The best model comes from a diverse pool of lenders. The FICO score covers a wide range. Now, the FICO score is actually made up of several submodels, and then they're all calibrated and aligned. But you don't see any of that. When you get the FICO score, you're getting a model that covers a broad range. You don't ask, unless you're extremely subprime, you generally don't ask, am I in the pool that FICO score was built from? Does FICO apply to me? You need to think that way when it comes to a shared data pool for modeling, that it's not whether you're close to the mean, it's just whether you're in the thick part of the data. So what's the range of the data set? Are you in the range? When you look at it that way, it's almost never that we see somebody fall out of the shared data pool for being too unique. Okay, now I want to use my last 10 to 15 minutes here to talk about how these models perform through cycles. And this is really important, and it should be a consideration on choosing certain models. So credit cycles, economic cycles, and CECL. Let me give you a little background. We've done work in the past, and in fact, we published a paper on the credit cycle through the mortgage crisis, and that paper came out in the Journal of Credit Risk back around April or May, I think. And we did that work jointly with Jose Canal Cerda of the Federal Reserve Board of Philadelphia, Federal Reserve Bank of Philadelphia. And that paper looked at credit cycles and where they come from. On this graph, the blue line is a measure of credit cycle for mortgage. And this is actually a few different studies put together that looked at different data sets, but we were able to come up with, the point is that you can see periods of low risk that tend to stretch for a while, and then sudden periods of high risk. And so the high risk periods were 95, 2000, 2001, 2006, 2007. Those high risk periods are always right before the recession, but the low risk periods are when you get the highest volume. And so basically what we're seeing in this right away is that high volume is when you get the best quality loans because everybody wants a loan. Really, this is about self-selection. There are times in the economic cycle when the good consumers want loans, and there are times when they stay home and only leave the others. And so you can look at this effect by looking at loan demand. This data is available from the Federal Reserve Board. It's called the Senior Loan Officer Opinion Survey. In fact, the FRED website, I think is it fred.gov? It may not be, but it's the economic data repository for the Federal Reserve. That's a good website for economic data, and this is loaded on there as well. We show more history than they do because we've gone back to older reports and stitched things together. But what you'll see is as you go through economic cycles, you get changes in consumer demand. Now, it's important to note consumer demand for different kinds of consumer loans and commercial demand for loans has been strong in 2012, 2013, 2014. And when we show the correlation, you'll see that that strength correlates to very good quality loans. In the last year, it's been hovering around neutral. And that's true for both consumer and commercial loans. Now, neutral loans tend to go with neutral quality, but these things trend. If you follow along here, you could put an arrow on these things. And right now the arrow is pointed down towards lower demand. What drives demand? Interest rates and asset prices. So what is that home going to cost me? How fast is the price of the home? Basically, what's the affordability of the home? And there's a little bit more to it. If home prices are falling, consumers get scared. But in the current environment, it's about affordability. Our prices rising too fast and our interest rates rising too fast. And you can see that on an affordability perspective, we're kind of puttering around neutral. So if you correlate consumer demand to credit quality, this has got to be one of the best correlations I've seen in trying to make retail lending models or commercial lending models. It's really good that you get bad quality when demand is low every time. So your best underwriting metric is, do consumers want loans? When you're in a situation where it's hard to get loans because demand is low, you need to be worried because the ones who do want loans are probably not the ones who you usually get, or I should say differently, you always write a certain amount of loans that are riskier, even at a certain FICO score. But the financially conservative consumers who tend to be skewed towards better quality, they go away when the economic environment is not right. And this is showing that those worst loans come when unemployment is at its lowest every time. Right now, this I should point out, there's a step up in credit quality here, better credit quality, because there was a change in Fannie Mae, Freddie Mac policies about what loans they would accept. So if you shifted that back down, took out that policy change, this would still be right on top of the pattern we've seen in the past. And so what it would say is that as unemployment gets better, quality is actually getting worse. And sometime in the next year to 18 months is probably when we face the greatest risk of the worst point in the credit cycle. Now, using all that, the question is, can a model measure the credit cycle? Can a model measure the economic cycle and include those things? So this graph, of course, you'll be able to see all these materials after the presentation, but this graph is worth spending time to understand because it's showing you which model performs the best. And I relabeled that historic average model to warm in this most recent study. So the black line on here is perfect foresight. This is what CECL wishes it could be. If in January 2008 you knew what the future total lifetime losses were going to be for the portfolio that you had on that date, it would be equal to 4% of the portfolio. Now that's pretty high, but that's what happened to us. And you can see that that number was increasing all the way back to January 2005 because lenders were booking more and more risky loans. But after mid-2008, they stopped booking risky loans. In fact, they stopped booking almost all loans for a while. And so the reserves would come down because the portfolio is shrinking and the risky loans are charging off fastest. So the black line is the ideal that we will never hit. This lavender line down here is the time series model, which you'll notice that the loss reserve level is flat for all that time, all the way up until mid-2008, and then it suddenly spikes up, and then it starts to come down. This lavender line is in agreement with some studies that we saw on CECL procyclicality. They just built time series models, and they concluded that CECL was highly procyclical. Procyclical means that the loss reserve peaks at the peak of the economic crisis, and so if procyclicality means that it would create a liquidity crisis. If you have to add to reserves at the peak of the crisis, you'd have a funding problem. And so if the only model you have available is a time series model, you might be saying that CECL is going to be a problem. Also, if you're looking at this warm model, warm may be simple, but really it's just the moving average on a longer time scale. And so it misses the recession entirely. It peaks in 2012 when all the danger has well passed. And so what the regulators have said is that you would use Q factors on top of warm. Well, the right way to use a Q factor is to put negative Q factors to delete warm after the recession and put them in to make it peak during or before the recession. To me, that's a useless model, to be blunt about it. It's not giving you anything useful here. So in between those two are the useful models. And let's look at the change. What really matters in your loss reserves is provisioning. Now, in provisioning, you have to add in losses that you had in the previous quarter. You have to refund the pool to compensate for that. So let's look instead just at the change in the loss reserves that each model predicts, because this tells you how much the model is going to help. And what it says is that the model, if your model is warm, it's useless until 2008 is the first point it starts to show added reserves. The time series model is essentially useless until 2008. On the other side, the best models on here are the vintage model and the survival model. They're about halfway to the reserves that would be added under the ideal. In the perfect case, you're about halfway to what you would add under that perfect model. So the vintage model, it's not the winner because of the accuracy measure. It's the winner here because it's looking at credit quality. It's able to pick up early on that the credit quality that's being booked is not the same as what has been in the past. And so it's really all about the credit cycle. The time series model is telling you that you can't predict the economic cycle, but the vintage model and the survival model are telling you that you can measure the credit cycle. And so that's where you have to ask, how much is it worth to you? Basically, I would say warm and time series are so bad they're almost useless. I would use them only if I had no other choice. One of the other models gives you some early warning. The roll rate and the state transition model are kind of halfway in between the vintage model and the no change model. So the reason they're halfway in between is that they pick up on delinquency changes, but delinquency is often driven by economic factors. And so they're still pretty strongly tied to that economic factor, and they kind of miss some of the credit quality changes because they're so focused on delinquency. Delinquency is a lagging indicator of what's coming. So how much early warning do you want? CECL is supposed to be about early warning, but that's the question here. The amount of investment you make in your model directly correlates to how much early warning you want. So how much is that early warning worth to you is what it comes down to. And in fact, I have another graph which I should have put in here and I didn't, which showed how much does your economic scenario matter. And we went out and bought economic scenarios for previous time periods and showed that the difference between the best economic scenario you could get at the time and a flat economic scenario was essentially irrelevant. The difference would be about 1 or at best case 2 quarters of early warning in your provisions. And so you can decide how much is 1 or 2 quarters of early warning worth to you in terms of paying for scenarios. So you can make that pretty concretely. But you can get 1 or 2 years worth of early warning by building a better model. So when it comes to what are you going to pay for, I would definitely pay attention to models. So that's my conclusion. Contact us if you have any questions, but we do have 10 minutes here where we can take any questions if people want to throw some in.
Thank you, Joe. One question that came up was, what about holdout samples, breaking apart your training set from development set to accomplish the validation?
Okay, good question. Holdout samples are good from an account level perspective. Note that in CECL, you don't have to do any account level modeling. The time series model, the roll rate model, the vintage model, they're not account level models. So the reason I make this distinction is that if you're building a behavior score, holdout samples are a totally standard thing to do if you have enough data. But the problem is that roll rate, time series, and vintage models are all looking at economic cycles and life cycle in the vintage model, and those are long time effects. So you can do some testing on the life cycle in a vintage model. If you said I have a 3 or 4 year period here and another 3 or 4 year period, I can compare the life cycles I get. So you need at least 6 to 8 years of data to do that test. For economic cycles, to do that holdout sample, you would need even more data. If you did back when we were worried about stress testing for a 1 or 2 year horizon, you might hold out the last 1 or 2 years, but that doesn't really tell you anything about except whether your model has a discontinuity in the forecast. And the reason I say that is that 1 or 2 years isn't going to have a recession, usually. The holdout sample concept is a good one, but if you think about economic cycles, we don't have enough data. So you do what you can, obviously, but it's not the answer we wish it could be. I will say that CECL is a big topic, and we get asked a lot of questions about data. What data should I include in each different model type? How do I handle missing values? All that stuff. We're happy to help with that. It's probably, as I said before, it's a talk unto itself. But let us know if you have any of those kinds of questions too.
I do have one other one that just came up here, Joe. What about reversion models? Have you looked into the best methods to calculate reversion rate?
It's an excellent question. Um, and a little background, many people are going to use two different models. They'll use a model that uses economic factors and basically their best model for the first 2 years. Even a lot of the largest lenders are planning to use something like their CCAR model for the first 2 years, and then use a through the cycle PD model for the rest of the life. Now, note that I said model because a through the cycle PD is not just an average number. You have to segment it in such a way that it aligns to your current portfolio. You have to ask, what is my current PD? What is my current portfolio? Because if I do a through the cycle PD that goes through the last recession, the loans that you have on the book today are not the same as what you had before the last recession. Generally, we all had a lot of riskier loans back then. So because of that, what a smaller group follow a more accurate approach, and this includes us. I do advocate that what you do instead is make your best model, but run it for the whole life cycle, not just for the first 2 years, but beyond 2 or 3 years, whatever you decide is your foreseeable period. I would say in your foreseeable period, use your economic scenario, whatever you think is a reasonable scenario. Beyond that, use a mean reverting algorithm for that economic scenario. These things are published, and in fact, I published exactly the math that we used for ours in the book, Mortgage Modeling Alternatives. So there's a chapter on there about how to do mean reversion. The technical term is that it's a second order diffusion equation. It's a second order Ornstein-Uhlenbeck equation, which is a term in the literature. You can find that on Wikipedia. And in discrete time, it's actually pretty simple. So we've got the formulas you can implement if you want. That's the best one I know of. So there you go.
Another question, how do the risk rating factors by loan affect the models?
Well, some of these models don't use them at all, like time series models. If it's a state transition model, that's exactly what you would do, is bin by your risk ratings and then predict the probability of transitions, and assuming and one of your states would be charge off. If you're doing a survival model or any kind of a PD model, then you take the risk rating as an input. And as an input, it's probably going to be a factor variable, meaning that you've got a different coefficient for each different state, that it's not just linear and it's not just continuous. Usually it can have some nonlinear structure you want to capture there, but it can just be an input to your model. And you can use those ratings as an input to your state transition model as well.
Question, what about splitting the development set over the same testing horizon, making sure the two pools are similar in composition? This provides an out-of-sample test, but not dependent on the time-based holdout. Wouldn't this be a viable option?
It tests part of your model. Yes, it will test your use of what I call scoring factors, which would be delinquency, FICO, LTV, anything refreshed, all that stuff. It is a good way to test the stability of your model on a holdout set for that. It won't test your economic correlations or your the adverse selection from the credit cycle. So, and I think in your question you recognized that. So yeah, it's a good partial solution.
Okay. Well, I think that we're coming up on our time here. I want to thank everyone for attending, and thank you, Joe, for your wisdom. Hope everyone enjoyed the session. So again, thanks for your participation in today's presentation, and have a great day.